Hello and welcome to another Pivotal Cloud Foundry demonstration. This video will take a look at some new technologies, Project Kubo, which is a BOSH release of Kubernetes, and then an automated installer for Spring Cloud data flow on top of Kubernetes. Okay, getting started, we'll take a look at the Kubo deployment GitHub site. This has all kinds of information on how to deploy Kubo and also some network topology diagrams based on where you're deploying Kubo. So we'll click the install guide. In the install guide, we'll see things broken down into some pretty specific steps around paving the infrastructure and then deploying the software itself. I went ahead and just took those steps and turned them into shell scripts so that I could automate the install a little bit and make things go faster. First step is paving the infrastructure. Here we'll give information about our target environment, and then the system will go out and create our networks and our BOSH Bastion host, as well as anything else it needs to complete the install. There's just a couple variables we need to provide, a prefix for our naming of our systems, and then a network that we'll deploy to. Then we can run the paving script and our infrastructure will all be created for us. Once that completes, we move on to the next step, which will be deploying BOSH onto that infrastructure. This script's pretty simple, so it'll run pretty quickly. So with BOSH installed, we'll take a look at the infrastructure to see what's been created. So a couple of different VMs have been created, as well as the networks. And the firewalls, routes, and everything else we need for connectivity. So now we'll move on to configuring GCP Ayahs routing. And this will really just set the system up to use the default GCP load balancing. So we can run the Ayahs routing script. And this will create our front end and back end load balancers. And then after that, we can move on to deploying Kubernetes. So we'll take a look at our deploy Kubo script. And it's really just a couple different commands for deploying and then setting up the environment. So now it's created all our VMs for Kubernetes and installed Kubernetes. And we can take a look at that. See all our new VMs. And if we look at the networks, we'll see some new routes. To try out our Kubernetes infrastructure, we're going to install Spring Cloud Data Flow. In this case, we're going to use Kubernetes Helm, which is the Kubernetes package manager, and a newly released chart, which is basically an application definition for Helm. And we'll use that to install Spring Cloud Data Flow. Once we've started the install, all the Docker images will be deployed into the cluster. And we'll get a report back. And then we can use this get service command to check and see when we get an external IP assigned to our Spring Cloud Dataflow server. Now we'll take a look at the Kubernetes Ui, and we'll see all the newly created pods that each have their own persistent volumes and the services associated. So here we see that external IP. If we look into the Google Cloud UI, we'll see that external IP is presented out. And now we just wait for the whole thing to come online. Once it's all online, you can check that service again and then go look at the UI. And Spring Cloud Dataflow is installed and operational. Now we'll build a very simple streaming analytics app to test out our install. So we can download the Spring Cloud Dataflow client. We'll get the IP, start up the system, and then we need to install the Spring Cloud Stream application starters. We'll install the ones that leverage Rabbit as our stream transport and Docker as well. We can look in the GUI and verify all those installed properly. And then we'll go to the Spring Cloud Dataflow samples site and we'll pull our species prediction app and we'll use that as our sample data flow. So we'll create our stream and then we'll deploy it leveraging the default load balancer. And once we deploy that, you'll see those pop up as pods. And since we're using our default load balancer on GCP, we'll get a load balancer and external IP configured. We'll see each of these sections runs as its own pod. And now it's live and operational. We have an external endpoint. And we can post information to that endpoint, and then we'll go back in and check the log to see if we got a correct prediction. So if we look at that log, we scroll to the bottom, we'll see that our prediction is indeed in place. So we have an operational data flow.